Hello and welcome to Mount Etna, an MEDC case study of a volcanic eruption. By the end of this presentation and the task that you complete, you will have a good detailed understanding of Mount Etna's location characteristics, its tectonic setting, including the nature of its volcanic activity, the timeline of its eruptive history, knowledge on the impacts that this volcanic activity has caused, and you will have detailed knowledge on how it's being managed. Mount Etna towers above Catania, the second largest city in Sicily, and it's Europe's highest volcano at a height of 3,310 metres. It is also its most active. It covers an area of 1,250 kilometres squared, and this is in the northeastern part of Sicily in Italy, as shown on the diagram in the right-hand corner. It's one of the world's longest documented records of eruptions, which dates back to 1500 BC, and we're looking at it as it's a case study where 25% of Sicily's population live on its slopes due to the benefits that volcanism actually provides, such as the rich fertile soil and also tourism. Lots of people go to visit due to its climate, but also due to the volcanic activity that they can observe there. Okay, so this page and what I've just talked about gives you the location characteristics. Make sure that you've made a note of these into your own notes. The next thing to consider is the nature of Mount Etna's volcanic activity. The type of plate margin is considered to be destructive plate margin, but it does have a very detailed history, and there has been continental rifting. Some volcanologists have linked it to hotspots, some have linked it to destructive plate margin. According to your chief examiner, David Redford, and the textbooks, we are going to learn that it is a destructive plate margin, and this is caused by the collision of the African and Eurasian continental plates. So I know previously I've taught you that where two continental plates collide, we get fold mountains. In this case, where the African plate meets the Eurasian plate, the African plate is more denser and acts like the oceanic plate does, and it subducts. As it subducts, the normal processes of magma generation, partial melting, slab dehydration, that happens, causing magma to then rise to the surface and form the volcano of Mount Etna. Because of its geological history and how complex it is, the type of volcano, well, there are a few different varieties on top of each other. So a series of nested stratovolcanoes or composite volcanoes are the main type of volcano, but on the sides of these volcanoes, we have got summit calderas. So in past, there have been secondary volcanoes where the gas has got contained within, been very explosive, has erupted, and then caused the sides of the volcano to collapse. So there is a central crater, a northeast crater, and a southeast crater, and these are collapsed craters, so the summit calderas. If we look even further at the base of the volcano, we have an old shield volcano, and that links to rifting in the past. Okay, so when we're talking about the type of volcano that Etna is, you start with the idea that it's stratovolcanoes. You've got the summit calderas where we get some explosive activity, and then we've got this old shield volcano on the base. To add to that, on the lower sides of the volcano, there are some fissures where magma is able to ooze out effusively, so nice and gently lava flows down the slopes, and that is basaltic magma. The type of magma and volcanic activity. Okay, because of the range of volcanic shapes we have, we've got a range of volcanic eruptions. So volcanologists have classified the eruptions as mostly effusive, so lava flowing onto the ground surface rather than exploding into the air. This is basaltic, it flows for quite far distances, hence why it can be quite dangerous to the townspeople of Catania that live on the slopes. But also, the eruptions are occasionally mild strombolian. They have short lava flows, and they occur on the summits from these calderas, so the central, the northeast, and the southeast. Okay. So, and then on the lower flanks, where we get these fissures and the lava flows, sometimes cinder volcanoes can be constructed over the top of the vents. Please make sure that you read and listened through this information and that you have notes in your own notes on the nature of Mount Etna's volcanism. What you have here is a diagram showing this generalised tectonic activity involved in the formation of Mount Etna. So you can see that we've got the island of Sicily in the centre, with Mount Etna being shown using the symbol of a triangle, like any map will show you normally. And you can see that the Eurasian plate is acting like the continental plate, and the African plate is acting like the oceanic plate and is subducting. The text there, the slab window, that is demonstrating where you have got dehydration melting. So as the African plate subducts underneath the Eurasian plate, the water contained within that plate is released, and that lowers the melting temperature of the mantle and of that plate, and as a result you get partial melting. So that's where some minerals in that plate are released, and they are less dense than the surrounding magma of the mantle, so they rise under pressure up underneath Sicily. They force their way up, and that's the magma that is producing the volcanoes and the volcano types discussed previously. So the principles that you would use to describe the action at this tectonic plate are basically the same as what we have done before when we've looked at destructive plate margin. It is acting like an oceanic to continental destructive plate. Your task is please draw a copy of this diagram into your notes and then describe and explain the process of subduction at this plate margin, as I've just talked you through, and then lead this on to how it is actually forming the tectonic volcanic activity at the Mount Etna. So how are we getting composite volcanoes from this? Okay, so Mount Etna has the longest documented history of any volcano in the world. What we're going to do is we're starting at 1669 and we're going to go right up to 2013. Now the page that you can see in front of you is a timeline of Mount Etna's volcanic activity and its impacts from 1669 to 2008. This has come from a whole source of different textbooks, mostly those written by your chief examiner. What I'd like you to do is read through this timeline and make a copy of it into your own notes. And what it gives you is details about the year and actually what happened and some impacts that the activity caused. Okay, leave room for years 2009 to 2013, which will be a website task I'm going to direct you into the next slide. Okay, so make sure you do get all this detail down into your notes, because Mount Etna is not just one eruption, it is a series eruption, and that's why it's very important that it is monitored. So it links to this case study of continuous monitoring. Okay. Once you've completed this timeline part here, the next slide will give you instructions for how to add it up to 2013. Okay, so having got up to 2008 in your timeline already, this website called Volcano Live gives you lots of information about lots of different volcanoes. What I've put in there for you is Mount Etna, and you can track back for very, very far in regards to the activity. But what I want you to focus on is from 2009 to 2013. So read through the information about the tectonic activity and add it to your copy of the timeline. So far we've done location characteristics, we've done the nature of the eruption, and we've done the timeline. The next page kind of links the timeline to the impact. So I provided you with a table summarising recent activity, impacts and responses to Mount Etna. What I want you to do is make a copy of the table into notes and then use a key to colour code the impacts into social, economic and environmental. There are other ways to be synoptic with impacts, but for this case study, can you just colour code them into these three criteria? So make a copy of the table, use three colours and colour code the impacts into social, economic and environmental. This is the table I was talking about. Okay, so you've got 4 columns, make a nice neat copy. You'll see that there is some information around the table that is not included. Please add that in. So the 2002-2003 lava flows destroyed the tourist stations comment, if you can add that into the October 2002 box. The comment at the bottom is estimated that only 77 confirmed deaths can be attributed to eruptions. You can leave that separate, or you could add an extra row on the top and put it as 1979. Okay, but please make sure you have a copy of this and you have colour coded it into social, economic and environmental. Okay, so we're moving on to management. A volcanic eruption cannot be prevented, but we can protect against the hazards to some degree, and we can predict if an eruption is going to happen. It's not an exact science though, so although we might be able to predict an eruption is going to happen, we cannot give an exact time for it, and sometimes eruption activity will die down, okay, but we cannot prevent it. Because we can protect and predict it, there are places such as Mount Etna, which experience frequent eruptions, we can put in actions into place to reduce the damage that it will cause and to save people's lives. So on the next 2 pages is a summary of the ways in which people and organisations have protected and predicted the volcanic of Mount Etna. Basically, I want you to read through it, and I want you to copy this information to your notes so you have a good detailed summary on what the organisations and people are doing along the slopes of Mount Etna, in the settlements surrounding Mount Etna, to protect themselves and to predict if an eruption is going to happen. So first of all, we have protection. So from your lesson, general lesson on how we manage the nature of eruptions, the impacts, protection means preparing for the event by modifying the human and built environments to decrease vulnerability. Okay, so how at risk people are, if they're older, if they're close to an eruption, that refers to vulnerability. But protection also includes attempts to modify the loss by insurance and aid. Also, it involves everyone from individuals to civil authorities. So I've taken 3 key areas for protection for Mount Etna and what they've done. So number 1 is dig trenches to divert lava. In 1669, the townspeople of Catania dug a tunnel to divert the lava away from their homes. This was successful, however, it did divert the lava to another town further down the slopes, so in the short term it was successful for Catania, but for the town that then got subsequently inundated with lava, it was a disaster. Number 2, build barriers to divert lava flow. An earth barrier of 750,000 cubic metres was built across the southern end of the Val de Bove area above the eastern crater in 1991. This was done to protect the town of Zaffarana. This was a temporary measure, whilst they put in other protective measures elsewhere. But in spring of 1992, this and the smaller barriers that led down into the valley of Zaffarana were overtopped. So it helped for a short period of time, but they then had to put other methods into action, which I'll talk about in a moment. They also used this technique in 2002, where they built dams of soil and volcanic rock at the base of the tourist base at Rifugio Sapienza, and helped to divert the flow. Okay, so this method of building barriers to divert and protect against lava flow has been used on 2 occasions with some temporary success. Explosive activity to try and divert lava flow is number 3. On the 23rd of May 1992, following the overtopping of the barriers that had been built, explosives were used near the source of the lava flow to disrupt it and to redirect it. So a lava tube system is where the top covers over, it hardens, and that keeps the heat inside the tube so that the magma inside it moves at a faster rate. So the explosions were used to break up that lava tube system, expose it to the atmosphere, and cool the lava down to slow it. This forced lava into a new artificial channel, as they were able to then divert it, and that took the lava away from Zaffarana. Okay, so that was a successful method they used. Prediction or monitoring. Prediction are methods used to identify whether a hazard will occur. So number 1, study the history of the volcano. So the Catania section of the Istituto Nazionale di Geofisica e Vulcanologia, INGV, a mouthful I know, has monitored the volcano for 20 years. So they have a long, detailed history of the eruption activity of the volcano. From this, they can identify hazard areas, they can look at previous flows, and they can work out what areas are at risk. Number 2 is to measure gas emissions, land swelling and groundwater levels. So geochemical monitoring programs at Mount Etna test the gas, the fluid emissions to help predict when new eruptions are going to happen and if dangerous emissions are being emitted, so that the levels have increased. The sulfur dioxide plume flux that occurs from the summit craters is routinely measured by a technique called correlation spectrometry, and this happens from a ground vehicle and from a helicopter. These are methods that you will have learned about in the general lesson on, how we protect and predict and prevent. Number 3, measure the shock waves generated by magma travelling upwards. So earthquakes can occur from tectonic activity, where plates move apart, move toward each other, and friction builds up. But they can also occur due to magmatic activity, where magma is moving up through the magma chamber, up the vent, and as a result, they will compress the rock around them, causing small tremors. So seismometers, the technique used to measure earthquakes, are used around Mount Etna slopes to measure earthquake activity from magma moving into the vent and forcing its way upwards. Make sure that you have all these detailed points about Mount Etna in your notes. So, having completed this presentation and the tasks outlined and talked to you about, you should arrive at next lesson with the following knowledge and understanding about Mount Etna. You should be able to tell me about its location characteristics, including where it's located, the percentage of people that live on its slopes. You then should be able to tell me about the nature of Mount Etna's volcanic activity. This includes the type of plate margin it is on, the type of volcanoes, and the complex geological history that caused the activity associated with it. You should have detailed knowledge on the timeline of its volcanic activity, especially in recent years. Highlights to consider are 1992 eruption and the 2002 eruption. Number 4, you should have a general understanding and a categorization of the impacts of Mount Etna's volcanic activity. And number 5, you should have knowledge and understanding on the management of Mount Etna's volcanic activity in terms of prediction and protection. Okay, I look forward to seeing you in the next lesson.